Okay, today we're going to be talking about Chapter 3, Section 3, so 3.3 ELR. We're still continuing what we did yesterday, which was a pretty long lesson on identifying those special angle pairs when you have parallel lines cut by a transversal. So we're going to be reviewing them again, except this time we're going to be talking about specifically what is a theorem, a postulate, a conditional statement. So we have some key terms here. A conditional statement, it is an if-then statement. So in the statement you'll see an if and then a then statement. The if statement has a hypothesis and then a then statement has a conclusion. We also have something called a postulate,
10 minutes.
which is an accepted fact.
In 10 minutes you can call her.
Another specific thing that's important is what is a theorem. So we're going to be using previous postulates, different definitions, previous proof theorems to actually prove a theorem. And then what's a converse is switching the hypothesis with the conclusion in a conditional statement. So all these things of properties of parallel lines, you can move it down, are given as an if-then conditional statement. So the first one, and we remembered we have to be able to locate these when we are looking at them on the parallel lines cut by the transversal, is called the same side interior postulate. So as long as the two lines are parallel, then that means that 4 plus 5 adds up to 180. 3 plus 6 also adds up to 180. If I ask you to write the converse of this if-then conditional statement, I am going to switch the hypothesis with the conclusion. So that means I'm going to say if, I'm switching now, if angle 4 plus angle 5 equals 180, then L must be parallel to M. So I switch the hypothesis with the conclusion to get the converse. Next one, alternate interior angles theorem. If I have L parallel to M again, right, if I have, and they have arrows to show us that, or they say it, then angle 4 is congruent to angle 6. So these are those alternate interior angles. Or I could have 3 equal to 5. How would I write the opposite, the converse of that? I would switch the conclusion with the hypothesis. So I'm going to say if angle 4 is congruent to angle 6, if that happens, then I know, yep, those lines are parallel. Alright, you can switch. Alright, we got 2 more left here. Alright, we have our corresponding angles theorem. If L is parallel to M, then all of these corresponding angle pairs are equal. So that means, let's review, 1 is congruent to 5. Those are corresponding angles. 4 is congruent to 8. Those are another set of corresponding angles. 2 is congruent to 6. Another pair of corresponding angles. And 3 is congruent to 7. If I wanted to write the converse, again, switch the hypothesis with the conclusion. So if angle 1 is congruent to angle 5, or any of these, then my lines are parallel. Okay, last theorem from this one is called the alternate exterior angles theorem. Again, if my two lines, L and M, are parallel, then that means that 1 is equal to 7. So those are on the outside, alternate. Or 2 is equal to 8, also on the outside, alternate. If I wanted to write the converse, I'm just going to flip this. So if I know that one of those sets of angles are equal, either one, then the lines are parallel. Okay, so I want to do 2 examples here, so you can move down. 2 different ones. So I'm giving you, what is the value of x if A is parallel to B? So we know these 2 lines are parallel. So if we have lines that are parallel, all of these things are true from these theorems and postulates. So we need to understand, okay, what kind of angles are 2x plus 9 and 111 degrees? So if you go through your notes, those two angles are called the same side interior angles. They're on the same side, they're inside. That means they add up to 180 degrees. So I'm going to set up my equation and figure out the x. So 2x plus, what's that, 120 equals 180. Subtract the 120 over. So I got 2x's to equal 60. Divide by the 2. So x is 30. So what is the value of x? 30. To make those lines parallel. Alright, last one. What is the value of w here if C is parallel to D? So they're parallel again, so that means all these things are true. We need to understand what kind of angles are these. Are they like what we just did, same side interior? They are definitely not, because this one's on the outside of the parallel line. So if you go through where things are located, those are corresponding angles. So they are equal. So I'm going to set up my algebra equation. 3w minus 2 is going to equal 55 degrees. And I'm going to solve the equation, adding 2. 3 times something to give me 57. Divide by 3. So what does that give us? 22, 19, I believe. So the value of w is 19 there, because those lines are parallel. You shut it off.